Hello there, and welcome to the Sleepy Space Channel. The one direction in the whole sky that no telescope has ever been allowed to search is also the one we know best of all. It is the direction of the sun, which floods the sky with light by day and hides behind the Earth by night, so that the space directly behind it is never once in our reach. And that blind spot is not empty. Something circles in there, closer to the sun than we are. A single point of space sits behind the sun and never comes into view, and people have wondered for a very long time whether a whole hidden world might be waiting in the glare. Tonight, we move slowly into the one part of the sky we were never meant to see. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is anything you need to carry. There is nothing hidden here that asks for your worry. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade gently away. Let's begin. There is one direction in the sky that no telescope on Earth has ever been able to search. It is not a faint or distant corner of space. It is the brightest and most familiar direction we know, the direction of the sun. Every morning the sun climbs into the sky and fills it with light, and in doing so it quietly erases everything that lies behind it. The stars are still there, just past the sun, exactly where they have always been. We simply cannot see them through the glare. For as long as people have looked upward, the sunward sky has been a bright and permanent blank. This is a strange thing to sit with, because we tend to think of the sun as the thing we see most clearly of all. We can watch it rise and set. We can feel its warmth on our skin. We can trace its slow arc across an afternoon. And yet the one place we can never look is the space directly behind it. The sun does not only give us light. It also takes a piece of the universe and holds it out of view, all day, every day, without pause. The glare is more complete than most people realize. The sun is not a small lamp hanging in an otherwise dark room. Its light pours into the whole sky at once, scattering through the air until the entire dome above us glows a pale and even blue. A star sitting a finger's width from the sun would have to shine through a sky thousands of times brighter than itself. The stars of daytime have not gone anywhere. They are simply drowned, and the water they are drowned in is sunlight. At night, the problem does not disappear. It only changes its shape. When darkness finally comes and the sky grows deep enough to reveal its faint detail, the sun has swung around to the far side of the Earth. The whole planet now stands between us and the sunward sky. The very direction we wanted to study lies buried beneath our feet, blocked by thousands of miles of rock. So the two things we need in order to see something faint, a dark sky and a clear line toward it, are never granted in the same direction at the same time. There is only one narrow compromise, and it arrives twice each day. In the last minutes after sunset, and again in the first minutes before dawn, the sun rests just below the horizon. Its part of the sky is still briefly lifted above ours, and the air has darkened just enough to let a little detail through. For a short while, a thin band of the sunward sky becomes reachable. Astronomers have learned to treasure these minutes because they are the only keyhole we have into the region the sun keeps hidden. The window is small, and it closes fast, and the light always returns. One might expect that leaving the ground would solve all of this, and for most of the sky it does. A telescope in space rises above the blurring, brightening air and can study the dark with a clarity no mountaintop can match. But no telescope, on the ground or in orbit, can escape the sun itself. To point a sensitive instrument too near the sun is to risk flooding it with light or scorching the very detector meant to gather starlight. So nearly every observatory we have ever built carries a strict rule written into its design, a wide circle of sky around the sun that it is simply forbidden to enter. This means the blind spot is not a small accident of standing on the Earth. It follows us upward. It follows us into orbit and outward among the planets. Wherever we place a camera, there tends to be a cone of space around the sun that the camera must never look into, on pain of ruin. The sunward direction is the hardest part of the sky to study from, nearly anywhere we have ever managed to go. We carry the blind spot with us, like a shadow we cannot set down. The result is a genuine hole in everything we have charted. We have mapped the night sky again and again, in ever finer detail, until it can seem as though almost nothing is left unseen. And yet, running quietly through all of that work, there is one region we have surveyed the least across the entire history of astronomy. It is the ring of sky that hugs the sun. The brightest thing we know sits at the center of our least known patch of space, and it has kept that patch to itself for a very long time. It would be easy to assume that this hidden region is simply empty, that there is nothing in it worth the trouble of looking. But that assumption has the logic turned around. We do not call the sunward sky empty because we have checked it and found nothing. We call it empty because we cannot check it at all. A blind spot never tells you what it contains. It only tells you where you are unable to look. Absence of sight is not the same as absence of things. It helps to notice how little of the sky the sun actually covers and how much it nonetheless hides. The sun's disk spans only about half a degree, a small bright circle you could hide behind the tip of a finger held at arm's length. If it merely blocked the space directly behind that disk, the hidden region would be tiny. But light does not stay inside the disk. It spills outward across tens of degrees until a great sweep of sky around the sun is lost to the glare. The sun conceals a region hundreds of times wider than the small circle it fills. The blind spot is also personal, in a quiet way. It is always centered on wherever the sun happens to sit from where you are standing. Two people on opposite sides of the Earth have their blind spots aimed in opposite directions at the very same moment. As the Earth turns beneath us, each of us carries a patch of forbidden sky, sweeping it slowly across the heavens from dawn to dusk. Everyone who has ever lived has had one, and no two have ever quite matched. For most of human history, the daytime sky was simply assumed to be blank. People saw the sun and the passing clouds, and beyond them, a featureless wash of blue, and it seemed only natural to think there was nothing more to see. Slowly it became clear how much that brightness was concealing. The same stars that fill the night are there in the day as well, wheeling overhead unseen, present and invisible at once. The blank blue was never empty. It was only bright. There is a single natural event that briefly lifts the veil, and people have always found it moving. When the moon slides exactly in front of the sun and covers its face, the glare drops away in the middle of the day. For a few minutes, the stars nearest the sun come out, and the pale outer light of the sun itself appears around the black disk of the moon. For those short minutes, nature does for us what we cannot do for ourselves. It holds a cover over the sun so that we may see what stands beside it. The rest of the time, we are left to our own devices. Those brief eclipses hinted at a lasting truth. If the glare could be blocked, even for a moment, things appeared that had been there all along. The space right next to the sun was not empty. It had only been overwhelmed. That single idea, that the trouble is the light and not the absence of things, runs underneath this entire subject. Much of what follows is the story of people finding ways to block the light and look calmly at what was waiting behind it. Studying the sunward sky from the ground has always been a discipline of patience and timing. The twilight observer does not have the luxury of long, calm exposures. There is a quiet race against the turning sky, a handful of minutes in which the target is both low enough to catch and dark enough to reveal. The sun is always either about to rise into the frame or has only just left it. Every image is stolen from the edge of daylight, and the light always wins in the end. And still, frame by frame, the patient work adds up. It is worth holding, too, the contradiction at the heart of all this. The sun is the most looked at object in the sky. It is the one thing every people has watched, measured, and arranged its days around. It is also the single greatest concealer of the sky that we have. The same object that lets us see everything else is the one thing we cannot see behind. The source of all our seeing is also the source of our largest blind spot, and it has been both of these at once for the whole of our history. None of this is a problem to be solved so much as a condition to be understood. We are not going to move the sun, and we would not want to. The blind spot is simply part of what it means to live beside a star, close enough to be warmed and lit by it. To ask what hides behind the sun is really to ask what it is like to see almost everything, except the one direction the light itself comes from. It is a gentle question, and it turns out to have surprisingly rich answers. And on the occasions when we have found ways to peer into that brightness, a little at a time, the sunward sky has turned out to be anything but empty. There are asteroids in there, circling closer to the sun than we do, permanently lost in its light. There are comets falling quietly toward it, seen only in their final hours. There is a single point in space that stays behind the sun forever, and around that point gather some of the oldest guesses people have ever made about hidden worlds. There is even a whole face of the sun itself, turned away from us, that we have never directly seen. Tonight, we move slowly through all of it. We will not hurry toward any single answer, because the quiet pleasure here lies in the patient accounting of a place we were never built to see. We will look at what the sun stands in front of as the seasons turn. We will look at the objects that hide in its glare, and at the rare ones that fall toward us out of that blind direction. We will look at the elegant trick that lets us build a small eclipse of our own and see past the light. And we will end at the strangest hidden thing of all, which is the far side of our own star. For now, it is enough to hold the simple shape of the idea. There is a direction we cannot look, and it happens to be the one we know best. It is not a dark and distant corner at the outer edge of everything. It is the warm and shining center of our own sky, the thing our days are built around. Everything that follows is only a slow walk around the rim of that brightness, into the stillness it keeps hidden behind itself. And there is no hurry at all in the walking. The gentlest version of our question has nothing to do with hidden asteroids or distant points in space. It is simply this: the sun is always standing in front of something, and whatever it stands in front of is hidden from us until it drifts on. To see this clearly, we have to remember that the sun does not sit still against the background of the stars. It moves, slowly, all the way around the sky, once a year. It is a curious thing to realize that the sun has a background at all. We are so used to seeing it alone in a blank blue sky that we forget it hangs in front of the same field of stars that fills the night. Those stars do not vanish when the sun is near them. They are simply there behind it, in the day, drowned in light, waiting for the sun to drift on and let them return. The sun is never really alone up there. It is always set against the same deep field as everything else. The rate of the drift is gentle, a little more than 1 degree a day, about the width of a couple of fingers held up to the sky. From one morning to the next, the change is far too small to notice. But it never stops, and it never reverses, and over the weeks it gathers, carrying the sun steadily forward through one region of stars and into the next, hiding each in its turn and freeing the one behind it. This slow, unwavering march is one of the most dependable motions in all the sky. The sun hides a given constellation at the same time each year and frees it at the same time each year, with a regularity you could arrange a life around. People have arranged their lives around it, in fact for longer than we have kept written records. The blind spot keeps a kind of calendar, patient and exact, and it has never once been late. The movement is not really the sun's own. It is ours. As the Earth travels its wide circle around the sun, our line of sight toward the sun sweeps steadily across the distant stars behind it. From where we stand, the effect is that the sun appears to creep forward through the fixed stars, covering a little more than 1 degree each day, until after a year it has traced a complete circle and returned to where it began. We are the ones moving, but the sun is the one that seems to walk. The path the sun follows through the stars has a name. It is called the ecliptic. It is not a random track. It is the flat plane of our own orbit, projected outward onto the sky, and the other planets keep close to it as well, because the whole solar system is built like a broad, flat disk. Strung along this path is a band of constellations, the familiar figures of the zodiac, and the sun passes in front of each of them in turn as the year goes by. Here is the quiet consequence. Whatever constellation the sun is standing in front of at any given time is, by that very fact, invisible to us. Its stars rise when the sun rises and set when the sun sets, and they spend the whole day lost in the glare. For a stretch of the year, every one of those constellations takes its turn directly behind the sun, hidden in the light, waiting. This is not a rare or unusual event. It is the steady rhythm of the sky. Each region of the zodiac spends roughly a month of every year washed out by the sun's brightness, and the rest of the year visible in the night. The band of constellations is like a long train slowly circling a station, with the sun always parked in front of one car at a time, hiding it from the platform where we stand. When a constellation finally emerges from behind the sun, it does so in the dawn. After weeks of being lost in the light, its stars appear for the first time low in the east, just before sunrise, rising a little earlier each morning. Then, over the following weeks, it climbs higher and shifts into the night sky. This first reappearance at dawn, a star returning from behind the sun, was one of the most closely watched events in the ancient sky. Long before anyone understood orbits, people noticed that certain bright stars vanished into the sun's glare for a season and then returned. The reappearance of a particular star at dawn could mark the turning of the year, the coming of the rains, the time to plant or to move the herds. Whole calendars were built on the moment a star climbed back out from behind the sun. The blind spot, in other words, was not just an obstacle. It was also a kind of clock. It is worth pausing on how much of this is happening at once. The night sky we see on any given evening is simply the half of the heavens that is turned away from the sun. The other half, the half behind the sun, is up there in the daytime, unseen. Every star we admire at night has its season of hiding, and every star hidden now will have its season of shining. The sky is always half revealed and half concealed, and the two halves are forever trading places. This is why the night sky changes with the seasons, a fact so familiar that we rarely ask why. The winter constellations and the summer constellations are different, not because the stars have moved, but because the Earth has carried us to the far side of our orbit. The stars of a winter night are the ones that happen to lie opposite the sun in winter. 6 months later, those same stars are behind the sun, hidden in the summer day, and a new set fills the dark. Nothing in this slow exchange is ever truly lost. A constellation that disappears into the glare is not gone. It is merely on the far side of the light for a while. Give it a few weeks, and it will return to the dawn, exactly as expected, in exactly the place the geometry predicts. The sky keeps perfect faith with itself. What goes behind the sun always comes back around. The planets play this game as well, and their version has a particular beauty. As they and the Earth travel their separate circles, a planet will now and then pass around to the far side of the sun from us. For a time it is lost, sitting almost directly behind the sun, invisible in the glare. Then it too swings clear and reappears in the sky, sometimes in the evening, sometimes at dawn, having spent its own quiet season in the blind spot. We have made this abstract truth quite concrete in the age of spacecraft. When we send a probe to another world, and that world passes behind the sun as the orbits align, we lose touch with it. The sun sits squarely in the path between us and our distant machine, and its roar of radio noise drowns out the faint signal. For days or weeks we simply wait, unable to speak to the craft, until the planet clears the sun and the connection returns. Even our voices cannot reach through the blind spot. Of all the things the sun stands in front of across a year, one is more beautiful than the rest, and it comes around like clockwork in the depths of northern winter. For a stretch of days near the shortest days of the year, the sun passes almost directly in front of the center of our own galaxy. The crowded, glowing heart of the Milky Way, the densest concentration of stars we can point toward, spends part of every winter hidden behind the nearest star of all. Consider what that means for a moment, gently. The center of the galaxy holds many millions of stars packed into a bright central bulge, along with the great dark mass that anchors the whole slow wheel. It is, in a sense, the most significant direction in our sky. And once a year, that entire crowded center is quietly eclipsed, not by anything grand, but by our own small, close, ordinary sun, which happens to lie in the same line of sight. On those winter days, if you could somehow switch off the sun's glare, you would be looking straight past it into the heart of the galaxy. The most concentrated starlight in our sky would be there, directly behind the pale winter sun, hidden in plain view. We stand with our backs to the long summer nights when that center rides high in the dark, and we forget that in winter it has simply slipped around behind the light. There is something restful in the regularity of all this. The sun does not hide things at random. It hides them on a schedule so precise that we can name the day a given star will vanish and the day it will return. The blind spot moves through the background in a slow, unhurried procession, taking each part of the sky in its turn and then letting it go. It is less like a thief and more like a slow tide, covering and uncovering the same shore. We tend to think of the stars as the very definition of things that are always there, fixed and dependable. And they are. But our view of them is not fixed at all. It is a moving window, carried around a great circle once a year, and at every moment a portion of the sky is closed to us behind the sun. To watch the whole sky, you cannot simply look up once. You have to wait and let the year turn and let the sun walk on. None of this requires any special instrument or effort. It happens above every one of us, all the time, whether we notice it or not. The sun rises in front of one piece of the sky and sets in front of it, and by the next season it has moved on to hide the next piece. The great slow shuffle of what is seen and what is hidden is one of the oldest and quietest motions in the world, and it asks nothing of us but patience. Before we go looking for the smaller and stranger things that hide in the sun's light, it is worth resting here for a moment, in the simplest form of the idea. The sun is always in front of something. There is always a part of the universe we are not being shown, held just behind the brightness, waiting for its turn to return. Tonight, as we drift, that hidden half of the sky is up there above the day somewhere, exactly where it should be, in no hurry at all. And the center of the galaxy will come back, as it always does. In a few months, the sun will have walked on around its circle, and on some clear night, the crowded heart of the Milky Way will rise again in the dark, unhidden, patient, unchanged by its season behind the light. Nothing behind the sun is ever truly gone. It is only, for a little while, out of sight. We turn now from the sky the sun passes in front of to the things that live permanently inside its glare. The first of these is a family of asteroids, small worlds of rock and metal that orbit the sun entirely inside the path of the Earth. They are among the least seen objects in the whole inner solar system, and the reason is exactly the one we have been circling. They are always near the sun in our sky, and so they are almost always hidden. It is worth savoring the strangeness of a whole class of worlds that live nearer the sun than we do. We tend to think of ourselves as close to the sun, the third of the inner planets, comfortably inside the cold outer reaches. But these asteroids are closer still, threading the warm space between our orbit and the sun in a part of the solar system we rarely picture as inhabited at all. The inner region is not empty. It has its own quiet residence, keeping to the light. Their days, if we could somehow stand on one of them, would be strange and bright. The sun would loom larger in their sky than it does in ours, its light fiercer, its warmth greater, filling more of the heavens. And the Earth, when it appeared at all, would be a small blue point far out in the darker sky beyond, one of the outer lights rather than the world at the center of things. From out there, we would be the distant ones, half the time lost in the glare ourselves. To understand why, it helps to picture where most asteroids spend their time. The great majority of the ones we track keep to orbits that carry them well beyond the Earth, out into the darker sky away from the sun. When such an object is on the far side of us from the sun, it rides high in the midnight sky, fully lit, easy to photograph against the dark. Night after night, patient surveys sweep that dark sky and catch them by the thousands. But a smaller group keeps entirely to the inside track. These are the asteroids whose orbits fit wholly within the orbit of the Earth, never straying out past us into the friendly night sky. They circle the sun closer than we do, and because of that, they can never appear far from the sun as we look out. From our vantage point, they are chained to the sun's neighborhood, forever caught in the bright part of the sky. The geometry is worth making plain, because it is the whole story. If an object never comes outside the Earth's orbit, then a line from our eyes to that object can never point very far from the sun. The asteroid is always somewhere near the sun in angle, off to one side of it or the other, but never opposite it, never high in the dark at midnight. It lives in the exact region we established at the start as the hardest to see. It lives in the blind spot. The practical result is that these interior asteroids are the poorly charted members of the inner solar system. While we have found many thousands of the objects that swing out into the night sky, we have found only a few dozen that keep entirely inside our orbit. This is not because they are genuinely so rare. It is because we can so seldom look where they are. We are missing them by the nature of the geometry, not by any true scarcity. This is one of those quiet cases where an absence in our records is not really about the things themselves. If you were told that only a few dozen of something existed, you might reasonably conclude they were precious and unusual. But here, the small number is an artifact of our position. The true population circling inside our orbit is certainly far larger than the handful we have managed to catch. Most of them have never once been seen, and are simply going about their orbits in the light. The innermost members of this family are the most hidden of all. Some of them loop so close to the sun that their entire orbit fits inside the orbit of Venus, our neighbor toward the sun. Such an object never in its whole existence appears in a dark sky from Earth. It spends every moment of every orbit in the region of glare, tracing its patient circle around the sun in a part of the heavens no ordinary night telescope will ever cover. It is a strange kind of hiddenness, because these are not faint, distant, dim things at the edge of the solar system. They are close, and they are sunlit, often more brightly lit than the asteroids we see easily, because they sit nearer the sun. In a fair, dark sky, many of them would be simple to spot. They are not hiding because they are dim. They are hiding because they stand too near the lamp, and the lamp is too bright to look beside. We know they must be there in part because of how the solar system is built. The inner region is not empty of small bodies. It is threaded with them, on every sort of orbit, and there is no reason the space inside the Earth's path should be swept clean. Objects wander inward over long spans of time, shepherded by the pull of the planets, and some settle for a while onto orbits that keep them entirely inside us. The interior is populated. We simply stand in a poor place to watch it. Finding even the few we know has taken real ingenuity and patience. The main tool is the twilight survey, the same keyhole we spoke of before. A telescope waits for the sun to drop just below the horizon and then scans the low sky in the fading or gathering light, racing to gather images before the twilight is gone. In those brief windows, now and then, one of the interior asteroids shows itself, a small point of light sliding through the glow near the horizon. A new generation of great survey telescopes now promises to widen this keyhole. These are instruments built to sweep enormous areas of sky again and again, night after night, and part of their gift is that they can spend some of their precious twilight time looking toward the sun. Minute by minute, twilight by twilight, they are beginning to fill in the blank region of the map, and the count of known interior asteroids has started, slowly, to climb. There is a cleverer trick still, which is to change where we look from, rather than only when. An asteroid near the sun is hard to see from Earth in reflected light, but it is warm, heated by the nearby sun, and warm things glow in their own heat, even when they are not easy to see by daylight. A telescope that senses that heat, placed on the sunward side of the Earth and looking outward, could catch these objects shining softly against the dark, no twilight race required. Such a vantage point turns the whole problem around. Instead of standing on the night side and squinting toward the glare, an instrument placed between us and the sun would have the sun at its back and the hidden inner regions spread out in front of it, lit and glowing. Objects that are nearly impossible to catch from the ground would sit there plainly, warm points against the cold. The blind spot, seen from the right place, stops being blind. It is worth sitting with the idea that our difficulty here is entirely a matter of position. There is nothing about these asteroids that resists being seen. They are lit, they are warm, they follow clean and predictable orbits. The only trouble is that we happen to be standing on the wrong side of the light. Move the observer, and the hidden becomes obvious. The objects were never the problem. The problem was always where we were looking from. These interior asteroids go about their business with complete indifference to whether we can see them. They circle the sun on their steady paths, warming and cooling as they swing nearer and farther, tumbling slowly, keeping the same orbits they have kept for ages. Our inability to watch them changes nothing about what they do. They are not lurking or waiting. They are simply there, in the light, being exactly what they are, whether or not a telescope ever finds them. Every so often, one of them is caught for the first time, and it is added quietly to the list. Its orbit is worked out, its size estimated, its path projected forward and back. And with that, one more of the hidden interior comes into the known solar system, no longer a member of the unseen population, but a charted object with a track we can follow. Each new one is a small reminder of how many more must still be out there, uncounted, in the glare. The picture that emerges is of a whole quiet district of the solar system that we are only beginning to survey. Inside the Earth's orbit, nearer the warmth, there is traffic we have barely begun to map, small worlds keeping close to the sun, most of them never seen. It is not a distant or exotic place. It is right next door, sunward of us, one of the closest regions there is. And it is nearly a blank on our charts, for no reason but the light. There is a gentleness in knowing that so much can be so near and still unseen. We sometimes imagine that the unknown must lie far away, out past the last planets, in the cold and the dark at the edge of everything. But here is a pocket of the unknown that sits closer to us than the sun, bathed in light, warm and busy, and almost entirely uncharted. The mystery is not always in the distance. Sometimes it is right beside the brightness. We will return, in a little while, to why these hidden inner objects are worth the patience it takes to find them. For now, it is enough to know that they are there, circling quietly in the glare, a whole family of small worlds keeping the sun close. They ask nothing of us and threaten nothing tonight. They are simply the first of the real things we have found waiting in the blind spot, and there is a soft satisfaction in knowing they exist at all. Picture them, if you like, as you let your thoughts slow, small stones of rock and metal, sunlit and warm, tracing their unhurried circles on the inside of our own, never once rising into our night. They have been there all along, keeping to the light, patient and unbothered. And little by little, in stolen minutes of twilight, we are learning their names and drawing them gently out of the glare and onto the map. The hidden interior is not only a curiosity for collectors of orbits. It connects to something more grounded, which is the simple fact that our watch on the sky has a blind side, and it is the sunward one. We keep a careful eye on the dark part of the sky, where objects are easy to catch. The bright part, toward the sun, is the one direction we cannot guard as well, and now and then something comes from there. We should be careful, here, to keep a sense of proportion, because it is easy to let a blind spot feel larger than it is. The sky is enormous, and the Earth is a small target within it, and the objects that might approach are spread thin across a great deal of empty space. The sunward gap in our watch is real, but the traffic that might use it is light. This is a matter of tidying up our knowledge, not of standing anxious guard against a crowded sky. Still, the tidying is worth doing, and there is a real satisfaction in doing it well. To know the objects that keep to the sunward side, to have their orbits charted and their paths projected forward, is to replace a vague unease with a clear and finished map. There is a particular calm that comes from turning an unknown into a known, even when the unknown was never very likely to trouble us. We do it in the end, because a complete map is a restful thing to hold. In time, if the work continues, the very idea of something arriving unseen out of the sun will simply fade away, not because the geometry has changed, but because we will have looked. The blind spot will have been mapped so thoroughly that nothing in it can surprise us. That is the quiet ambition behind all the twilight surveys and all the proposed sunward watches. It is not to conquer a danger, but to finish a map and to be able to rest in its completeness. To see why, remember how we find the objects that pass near the Earth. The great sky surveys that track them do their work at night, looking away from the sun, into the dark where a small rock shows up plainly as a moving point of light. This is where nearly all of our discoveries are made. It is patient, systematic work, and it has charted a great many of the objects whose paths bring them into our neighborhood. But an object that approaches us from the direction of the sun is hidden in exactly the region those surveys cannot sweep. It comes in out of the glare, riding the daylight, keeping close to the sun in our sky the whole way in. There is no dark patch for it to cross where a camera might catch it. It stays in the one part of the sky we are least able to watch, right up until it arrives. This is not a failing of care or diligence. It is a matter of geometry, the same geometry we have followed all along. If something comes at us from the sunward side, then to look for it, we would have to look almost straight at the sun, and that we cannot do. The watchers are not asleep. They are simply forbidden by the light from looking in the one direction the object happens to be coming from. The clearest reminder of this arrived within living memory, when the largest object to strike the atmosphere in about a century came down without any warning at all. It fell out of the morning sky, from the direction of the sun, and no telescope on Earth had seen it approach. It was not small, and it was not missed through carelessness. It was simply in the blind spot the entire way in, hidden in the glare until the moment it entered the air. It is worth being clear and calm about what that does and does not mean. It does not mean the sky is a shooting gallery or that we are in nightly peril. Encounters of any real size are rare, spread across long stretches of time, and most of what falls is small and harmless. What the event marks is something quieter and more humbling, that our coverage of the sky is not complete, and that the gap is on the sunward side, exactly where it has always been. Think of it as the one direction we do not watch well, rather than as a threat looming over us. A house may have windows on every side but one, and be perfectly safe for a lifetime, and still it is worth knowing which wall has no window. The sunward direction is our windowless wall. Nothing about that fact needs to trouble a quiet evening. It is simply useful to know where the blind side lies. Knowing where the gap is has, in fact, become the whole point. Once you understand that the sunward direction is the weak place in our watch, you know exactly where to put your effort. And so a good deal of thought now goes toward that bright region, toward finding ways to see into the glare and catch the things that keep close to the sun. The blind spot, once named, becomes a task rather than a fear. The first approach is the one we have already met, the twilight survey. By spending precious minutes at dusk and dawn scanning the low sky near the sun, the great survey telescopes can begin to catch objects that keep to the sunward side. It is slow and it is limited, but every twilight adds a little more coverage to the direction we most need to guard. The keyhole is narrow, but it is being worked, patiently, night after night. The more complete answer is to stop standing on the night side of the Earth altogether and to place a watcher closer to the sun. A spacecraft set on the sunward side of us, looking back outward and off to the sides, would have the whole inner region laid out before it, lit and open. From there, the space between the Earth and the sun is not a wall of glare. It is simply a well-lit stretch of sky, easy to survey. Such a watcher works best if it senses heat rather than only reflected light. An object near the sun is warm, and it glows in that warmth, and a telescope tuned to feel that glow can pick it out even against the background of space. Placed sunward and looking outward, an instrument like that would catch the warm, close objects that the ground can barely reach, and it would see them coming while they were still far off, with time to spare. The aim of all this is not alarm but simple foresight. If we can chart the objects that keep to the sunward side, then there are no arrivals out of the blind spot, only known objects on known paths, tracked long in advance. The goal is to turn the one direction we cannot watch into a direction we have already mapped, so that nothing needs to be feared from it, because everything in it is accounted for. Foreknowledge is the whole of the comfort here. It is a curiously hopeful project when you look at it plainly. For most of history, the sunward sky was simply a place we could not go and did not watch, and we lived under it without a thought. Now, for the first time, we are learning to see into it, to fill in the last blank quarter of the sky, and to replace a blind spot with a chart. The oldest unwatched direction is finally being watched. There is something fitting in the fact that the hardest region to see is the one lit by our own star. The sun gives us the light by which we see everything else, and in return, it keeps one direction to itself. To look into that direction, we have had to be inventive, to steal minutes of twilight and to send our eyes closer to the sun than we can go ourselves. It has taken effort precisely because it is the direction the light comes from. None of this is a burden to carry into the night. The watch goes on without us, quietly, in twilight minutes, and in instruments placed toward the sun. The sky is enormous, the encounters are rare, and the work of mapping the last blind quarter is already underway. There is nothing here that asks for worry. There is only the slow, reassuring labor of turning an unknown direction into a known one. If anything, the story is a gentle one about attention. We learned where we were not looking, and instead of turning away from it, we turned toward it. We found the one wall without a window, and we began, carefully, to cut a window into it. That is not the story of a danger. It is the story of a blind spot being patiently, deliberately closed, a little more with every pass of a telescope through the twilight. So we can let the sunward objects rest where they are, warm and mostly harmless, circling in the light. The rare traveler that once might have come unseen out of the glare is exactly the thing we are now learning to catch in advance. The direction we never used to watch is becoming a direction we do. And the night sky, as ever, remains the well-guarded half, dark and open and thoroughly known. We have spent this part looking at the practical face of the blind spot, the reason it is worth the trouble of seeing into. But the sunward sky holds gentler things than incoming rocks, and stranger ones too. Having found a reason to look into the glare, we can now turn to the beautiful trick that lets us look into it deeply, and to the quiet, falling visitors it reveals. The tools we built to guard the blind spot also let us wander through it. Let us gather, for a moment, what we have found so far, before we go on. We began with a single direction we can never look, the sunward sky, hidden by day in glare and by night behind the earth. We saw that the sun stands in front of a different piece of the background each season, hiding the constellations and even the center of the galaxy in their turn. And we found real objects living in that blind spot, a family of asteroids circling inside our orbit, warm and lit and almost never seen. Now we come to the tool that lets us look into the brightness on purpose. The idea of covering the sun to see what lies beside it is older than any spacecraft, and it began with people chasing the shadow of the moon across the world. For a long time, the only way to see the sun's faint surroundings was to travel to wherever a total eclipse would fall and wait for those few minutes of daytime darkness. Whole journeys were undertaken for one short look at the covered sun. The knowledge was real, but it was rationed by the rare alignment of sun, moon, and earth. What changed everything was the simple realization that the moon was not required. A small disk, held at just the right distance inside a telescope, could do the moon's work whenever we wished, blocking the bright face and leaving the surroundings open to view. The eclipse became something we could carry, something we could keep running for as long as we liked, rather than something we had to travel to and wait for. The rarest few minutes in all of astronomy became, in effect, always available. There is a real elegance in solving a problem of too much light, not with more power, but with a well-placed shadow. The instinct might be to build an ever larger telescope to overpower the glare, but that is not the answer here. The answer is subtraction, to take away the one overwhelming source and let the quiet things that were there all along step forward on their own. It is a gentle kind of cleverness, and it suits the gentle things it brings to light. The problem all along has been the light itself. The things near the sun are not dim, they are simply outshone. So the natural solution is not to build a bigger telescope or a more sensitive eye, but to do something much simpler: block the sun. If you could cover just the bright face of the sun and leave the sky around it open, then the faint things beside it would step out of hiding, exactly as they do in the brief minutes of a natural eclipse. This is precisely what a certain kind of instrument does. It carries a small disk held at just the right place inside the telescope, positioned to cover the sun's face and nothing more. With the disk in place, the overwhelming light of the sun's surface is stopped before it can flood the image, and the much fainter surroundings become visible. It is, in effect, a permanent, portable eclipse, built into the instrument and available at any hour. The value of this is hard to overstate, because a natural eclipse is such a rare and fleeting thing. To wait for the moon to cover the sun is to wait years, and then to be granted only a few minutes in one narrow strip of the world if the sky is clear. An instrument that makes its own eclipse is free of all that. It can hold the sun covered for hours, for days, for years on end, and study the region around it whenever it likes. It never has to wait for the sky. Placed aboard a spacecraft between the Earth and the sun, such an instrument keeps that artificial eclipse running without pause. Hour after hour, it holds its small disk over the sun and watches the space immediately around it, a space we on the ground almost never get to see. It has turned the very center of the blind spot into one of the most continuously watched patches of sky there is. The most hidden region became, for this one instrument, a place under constant, patient observation. When the sun's face is covered, the first thing that appears is the sun's own outer light, the pale, faint atmosphere that surrounds it. This outer light streams away from the sun in soft plumes and streamers, reaching far out into space, always there but almost always invisible, swallowed by the brilliance of the surface. Only with the surface blocked does it emerge, a quiet halo standing out around the dark disk, gentle and structured and slow. The outer light of the sun is not a smooth, even glow. When it is revealed against the covered disk, it shows a delicate structure, drawn out into long streamers and soft plumes that reach away from the sun in graceful shapes. These forms are shaped by the sun's magnetism, and they shift slowly over days and weeks, so that the covered sun is never quite the same from one long look to the next. It is one of the loveliest sights the artificial eclipse brings into view. To watch this faint outer light steadily, hour after hour, was something people had wanted for a very long time. In the brief minutes of a natural eclipse, there was never time to study it properly. It appeared, and then the sun returned, and the watchers were left with only what they could remember and sketch. The instrument that holds its own eclipse changed all of that, giving us the outer sun to observe at leisure, calmly, for as long as we cared to look. But the truly surprising harvest of these sun-blocking instruments was not the sun's own atmosphere. It was the comets. With the glare held back, the watchers began to catch small comets falling in toward the sun, one after another, in numbers that no one had expected. Over the years, the count climbed into the thousands. A whole population of small, faint comets, forever lost in the glare from the ground, revealed itself the moment the sun's face was covered. Many of these comets belong to great families that share a common path, all of them falling almost straight at the sun on long, plunging orbits. They come in from the far reaches of the solar system, gathering speed as they fall, until at last they round the sun at tremendous speed, skimming close above its surface. For most of their long journey, they are much too faint to see. Only in the final stretch, as they near the sun and warm and brighten, do they come into view. And they come into view in the one place we could never watch from home. They appear near the sun, in the blind spot, and so it is only the artificial eclipse that ever catches them. On the images from the sun-watching spacecraft, a comet will emerge from the edge of the covering disk, a small, bright smudge with a thin tail, sliding inward toward the hidden sun. For a few hours it brightens as it falls. And then, very often, it is simply gone. Many of these small comets do not survive their close pass. They have fallen so near the sun that its heat boils them away, unwinding them into gas and dust, until nothing coherent is left. They arrive out of the dark, blaze briefly beside the covered sun, and end there, in the glare, unmaking themselves in the light. We see the whole of their visible lives, sometimes only a day or two of it, played out against the black disk of the artificial eclipse. There is a quiet poignancy in these falling comets, if you let yourself feel it gently. Each one has traveled for a very long time, from very far away, on a single long fall toward the sun. And the only part of that journey we ever witness is the end of it, the last bright hours beside the star. They were invisible for the whole of their approach, and they will be gone just after. We catch them precisely in the blind spot, precisely at the close. Not all of them perish. Some sweep around the sun and back out again, skimming close and then climbing away, their orbits carrying them out into the dark once more. On the images you can watch such a comet slide in on one side of the covered sun, disappear behind the disk for a while, and then reappear on the other side, thinner and fainter, but intact, heading back out the way it came. It passed through the deepest part of the blind spot and lived. It is worth pausing on that image, because it is a rare gift to watch something pass behind the sun and come out the other side. For so much of this subject, what goes behind the sun is simply lost to us until it clears the glare on its own. But here, with the artificial eclipse running, we can follow a comet almost the whole way, in on one side and out on the other, keeping watch across the very region we are otherwise forbidden to see. These instruments have quietly rewritten how many comets we know of. A large share of all the comets ever recorded were found this way, near the sun, by machines holding a disk over its face. Most of them will never be seen again, either because they were destroyed or because their long orbits will not bring them back for ages. They are known from a single passage, a few hours of brightness beside a covered sun, and then a return to the dark and the unknown. Consider what a strange kind of acquaintance that is. We meet these comets once, for a few hours, at the very end of their long lives, in a place we could never otherwise see. We learn a little of where they came from and how they moved, and then they are gone, most of them forever. Our whole relationship with such a comet is a single brief encounter beside the sun. And yet from it we learn that the comet existed at all, which is far more than we would ever have had otherwise. Multiply that by the many thousands, and a picture forms of a steady, gentle rain of small comets falling toward the sun, going on all the time, mostly unwitnessed. Before we learned to cover the sun's face, this rain was entirely invisible. The comets fell and ended in the glare, unseen and uncounted. Now we know the rain is there, quiet and continual, a slow inward drift of icy travelers meeting the sun one by one. The blind spot, it turned out, was far busier than anyone had supposed. The lesson of the artificial eclipse is a hopeful one, and it runs against the grain of the whole subject. We spent the earlier parts of this account establishing that the sunward sky is the hardest place to see. And then, with one simple idea, a small disk in the right place, we turned that hardest place into one we can watch continuously. The blind spot did not have to stay blind. It only took the patience to cover the light and look past it. There is also something restful in how it works. There is no straining here, no fighting the glare with ever greater power. There is only the quiet act of covering the source of the trouble and letting the faint things appear on their own. The comets were always falling. The sun's soft outer light was always streaming. Nothing new was made to happen. We simply stopped the brightness for a while and let what was already there become visible. So the artificial eclipse gives us our clearest window yet into the blind spot, and it shows us that the region is alive with slow, quiet motion, an outer light forever streaming from the sun, and small comets forever falling in toward it, brightening and vanishing beside the covered disk. It is a gentle kind of traffic, played out in a place we were never meant to see, watched now by patient machines that hold the sun in shadow. We have looked, so far, at things that move through the blind spot, the seasonal sky, the circling asteroids, the falling comets. But there is also something in the sunward direction that does not move at all, a fixed point that stays behind the sun forever, never rising, never setting, never clearing the glare. It is toward that permanent hidden place that we turn next, and toward the very old dreams that have gathered around it. Everything we have followed so far has been in motion. The constellations drift behind the sun and out again, the asteroids circle, the comets fall. But there is one thing in the sunward direction that never moves at all, relative to us. It is a point in space that sits permanently behind the sun, always directly opposite the Earth, and it never once rises, sets, or clears the glare. To reach it, we have to think for a moment about how balance works in the space between two bodies. It helps to slow down and picture the situation plainly. The Earth and the Sun are two bodies, one small and one enormous, and between and around them the pull of gravity forms a kind of invisible landscape, with slopes and hollows and high points. An object set loose in that landscape will tend to slide, drawn by gravity and carried by its own motion, towards some places and away from others. The balance points are simply the special spots where, for a moment, there is nowhere left to slide. Most of that invisible landscape is all slopes, and an object placed at random will simply fall one way or another, pulled toward the sun, or flung outward, or drawn toward the Earth. But at a few precise locations, the slopes cancel, and an object can rest as if on level ground, keeping pace with the Earth as it circles the sun. These few level spots are rare and useful, and each has become, in its own way, a piece of quiet real estate in the space around us. We have learned to make use of several of them. The level spots near the Earth make fine places to park an instrument, steady and convenient, and we have sent machines to sit at them. The level spots far off to the sides gather natural company, small asteroids that have settled there over long ages. Each balance point has its character and its use. All except one, the one across the width of our orbit, behind the sun, which is good for nothing at all except being hidden. When one body circles another, as the Earth circles the sun, there are a handful of special places nearby, where the forces at work fall into a kind of standstill. At these places, the inward pull of gravity and the outward tendency of orbital motion are tuned so finely against each other that a small object left there can keep pace with the Earth, going around the sun in step with us, neither falling behind nor pulling ahead. There are 5 such places in the Earth and Sun system, and each has its own character. 2 of them lie close to the Earth, one on the side toward the sun and one on the side away from it. These are useful and much visited. We have placed instruments at both, because from there a spacecraft can hold station near the Earth with very little effort while enjoying a clear, steady view. 2 more sit far off to the sides, sharing the Earth's orbit but running well ahead of us and well behind us, and these have a gentle strength that lets them gather and hold small objects over long ages. It is the 5th one that concerns us here. This is the balance point that lies on the far side of the sun, directly opposite the Earth, out across the whole width of our orbit. If you were to draw a straight line from the Earth through the center of the sun and continue it the same distance again on the other side, you would arrive at it. It keeps pace with us as we both circle the sun, staying always exactly behind the sun as seen from where we stand. Consider what that placement means for our ability to see it. From the Earth, this point is never anywhere but behind the sun. As we move along our orbit, it moves too, matched to us, staying always on the far side of the sun in our line of sight. It does not swing out to one side in the evening or climb into the dawn. It has no season of visibility, the way the hidden constellations do. It is, of all the places we have discussed, the single most reliably hidden one, screened by the sun at every hour of every day of every year. In principle, it is a real location we could name and point to, the way we might point to any landmark we cannot currently see. We know exactly where it is. We can calculate its position at any moment with great precision. And yet, no one standing on the Earth has ever seen it, or ever could, because the sun is always squarely in the way. It is a charted place that is also a permanently unseen one, which is a rare and strange combination. Now, one might imagine that such a balance point would quietly gather objects over time, the way the 2 points off to the sides do. Those side points are gentle traps. Small asteroids have drifted into them and settled, keeping station there for ages, and we have found them. It would be natural to suppose that the point behind the sun might collect its own hidden company in the same way, out of our sight. But it does not, and the reason is important. The point behind the sun is not a stable trap. It is a balance, but a delicate and unforgiving one, like a ball resting on the top of a smooth hill rather than sitting in the bottom of a bowl. The slightest nudge, and an object there begins to drift away, and once it drifts, it does not return. And there are always nudges, because the other planets, circling on their own paths, tug gently at anything sitting at that point, never letting it rest for long. So the point behind the sun does not accumulate a hidden population. An object could be placed there, but it would not stay. Over time, it would wander off, pulled loose by the patient gravity of the other worlds. This is a quiet but decisive fact, and it will matter a great deal in a moment, because it is the first and simplest reason that certain very old dreams about what might hide behind the sun cannot actually be true. It is worth dwelling on how finely balanced the whole arrangement is. These points exist because gravity and motion can be tuned against each other, but the tuning is exact, and the solar system is not a simple place of 2 bodies alone. It is a system of many worlds, all pulling on one another in an intricate, ever-shifting way. A balance that would hold perfectly in an empty universe becomes, in the real solar system, a place from which things gradually slip. Perfection on paper becomes patience in practice. For the purposes of a spacecraft, the point behind the sun is also nearly useless, and it is worth saying why. It sits across the entire width of our orbit, far from the Earth, and it is unstable, so anything there would need constant effort to stay in place. And it is behind the sun, which means we could not easily speak to a machine placed there. The sun would sit between us and it, drowning any signal. It is one of the most awkward places in the whole neighborhood to put anything, precisely because it is so thoroughly hidden. In a way, the point behind the sun is a small lesson in how the universe declines to be convenient. It would be a tidy thing if the most hidden place were also the most useful one, a natural vault where objects gathered and stayed. But the arrangement is the opposite. The one point that is perfectly and permanently hidden is also unstable, awkward, and empty, holding nothing and keeping nothing. Its only quality is its hiddenness, and hiddenness alone turns out to be a rather thin thing to possess. And yet that thin quality was, for a very long time, enough to make the point behind the sun feel important. A place you cannot see invites the mind to fill it, and this place is unusual in being not merely unseen for a season, but unseen forever. Of all the hiding places the imagination might reach for, none is more complete. It is little wonder that people turn to it whenever they wish to imagine something kept permanently, perfectly out of view. And yet its very hiddenness has always given it a certain pull on the imagination. Here is a place, real and locatable, that is guaranteed to be out of our sight forever. If you wish to imagine something you could never quite catch, something that stayed always just behind the brightness, this is exactly where you would put it. The point behind the sun is the natural home for anything one wants to keep hidden, not because things gather there, but because nothing there can ever be seen. Down the centuries, that is precisely the use to which people have put it, in their minds. The point directly behind the sun became the imagined hiding place for a hidden world, a secret companion to the Earth, tucked forever out of view. It is one of the oldest guesses about what might live in the blind spot, and it is worth taking seriously and gently, both for the beauty of the idea and for the care with which we now know it to be untrue. Before we follow that dream, it is worth holding the plain picture of the place itself. Out across the width of our orbit, on the far side of the sun, there is a quiet point in empty space, keeping pace with us, screened by the sun at every moment. Nothing rests there for long. It is not a hiding place after all, only a place that cannot be seen. The distinction is subtle, and it is the whole difference between a mystery and a myth. There is a certain calm in a hidden place that turns out to be empty. We are so used to the idea that the unseen must be full of something, that behind every closed door there must be a presence. But here is a location we genuinely cannot see, and what it holds is nothing at all, only balance and drift and the steady pull of distant worlds. The blind spot has a center, and the center is quiet, and there is nothing in it that needs watching tonight. So we can let the point behind the sun be what it is, a real address in space with no one home, a balance too delicate to hold a guest, forever screened by the star it circles alongside us. It asks nothing and hides nothing, though for a very long time people were sure it must be hiding a world. To that ancient and lovely idea, the dream of a twin of the Earth kept always behind the sun, we now turn, with affection and with care. Long before there were telescopes, long before anyone understood how the planets truly moved, some of the earliest thinkers about the sky proposed that a whole world might be hidden behind the sun. It is one of the oldest guesses humanity ever made about the blind spot, and it is worth telling gently, because it comes from the same simple wondering we began with. If there is a direction we cannot look, what might be waiting in it? There is a reason this particular guess appears again and again, across different times and different peoples. It answers a very human discomfort with the idea of a place we cannot check. The mind does not easily accept a blank. It wants to fill the unseen with something, and a hidden twin is one of the most natural things to imagine, because it mirrors the world we already know. If there is a place we cannot see, let it hold a second version of the place we can. It is an old and comforting kind of reasoning. The counter-Earth also carried in some tellings a certain quiet poignancy, the notion that we might have a companion we would never meet, a world as full and real as our own, sharing our exact journey and yet forever out of reach behind the sun. There is a loneliness to that image, and also a strange comfort in it, the thought of not being entirely alone on our path, even if the company could never be seen. Ideas like this endure because they answer feelings as much as facts. But feelings, however deep, do not place a world in space, and the test of the counter-Earth was always going to be whether the heavens actually allowed it. That is the quiet discipline that separates a lasting truth from a lasting wish. It is not whether an idea is beautiful or comforting, but whether the world, examined with care, turns out to be arranged that way. And so the counter-Earth had to be measured against what we could learn of orbits, of gravity, and of the view from elsewhere in the sky. The idea took shape in a picture of the heavens quite unlike our own. In that early scheme, the Earth was not the center of everything, but circled a great central fire along with the other bodies of the sky. And to complete the arrangement, the thinkers imagined another world, a counter-Earth, circling on the far side of that central fire, always positioned so that it stayed hidden from us. It was, in a sense, the first serious attempt to populate the unseen part of the sky with something real. This counter-Earth was a twin of our own world, a mirror kept always out of view. Wherever we went, it went too, matched to us across the fire at the center, forever on the opposite side, forever screened from sight. It was a beautiful and strange notion that we might have a companion world we could never see, going everywhere we went, sharing our journey around the center of things, and yet always hidden by the very thing we both circled. When our understanding of the heavens changed, and the sun took its place at the center, the old dream did not entirely fade. It simply moved. Now the imagined hidden world became a planet keeping perfect step with the Earth on the opposite side of the sun, tucked always behind it, matched to our motion so exactly that the sun would always stand between us. The counter-Earth had found a new home at that same permanently hidden point across the width of our orbit. It is easy to see why the idea held on for so long. It answers, in the most direct way possible, the question the blind spot invites. There is a place we can never see, so why not a world in it, a twin of our own, sharing our path unseen? The thought has a pull to it, a quiet appeal to the part of us that suspects the hidden must be full. A mirror Earth behind the sun is exactly the kind of thing the imagination wants the blind spot to hold. But we are no longer confined to guessing, and the counter-Earth, lovely as it is, cannot actually be there. There are several reasons, and they fit together into a quiet and complete certainty. It is worth walking through them slowly, not to dismiss the dream harshly, but to see clearly why the space behind the sun is empty of twins, and to appreciate how thoroughly we have come to know a place we cannot see. The first reason we have already met. The point directly behind the sun is not a stable resting place. It is a delicate balance from which any object slowly drifts, tugged loose by the gentle pull of the other planets. A whole world could not simply hang there forever, matched to us in perfect secrecy. Over time, it would wander from its hiding place, drift out from behind the sun, and swing into view. A hidden twin could not have stayed hidden. The sky would not allow it. The second reason is a matter of weight, and it is decisive. A world the size of the Earth is a heavy thing, and heavy things make themselves felt through gravity, whether or not they can be seen. A twin planet on the far side of the sun would pull on the other worlds of the inner solar system, tugging at their orbits, shifting their motions in ways we would long ago have measured. The clockwork of the planets fits together far too precisely to conceal an extra Earth inside it. We have watched the motions of the planets for a very long time and mapped them with enormous care. Their paths are known to a fine degree, and they are exactly what the visible worlds pulling on one another should produce. There is no unexplained tug, no leftover wobble, no hidden hand shifting things from the far side of the sun. If a twin of the Earth were there, the other planets would have told on it. Their silence is its absence. The third reason is perhaps the most beautiful, because it is the one that most fully answers the whole spirit of the question. We no longer look only from the Earth. In our time, we have sent machines out across the solar system, in wide arcs around the sun, off to the other planets, out toward the edge of things. And from those distant vantage points, the far side of the sun is not hidden at all. What is behind the sun for us is out in the open for a spacecraft on the other side of it. Think of what that means for the old dream. A counter-Earth is hidden only from the Earth, only because the sun happens to lie between. But a camera off to one side, out among the planets, has no such blind spot in that direction. It looks toward the sun from a different angle and sees the space around it that we cannot. We have, in effect, scattered our eyes across the solar system, and among them are eyes that have looked squarely at the place behind the sun. And they have found no twin. The far side of the sun, seen from those other vantage points, holds no hidden world keeping step with us. The one place we on Earth can never look has been looked at, from the side, by our own machines, and it is empty of any companion Earth. The blind spot has been checked, not from where we stand, but from where we have sent ourselves, and the checking is complete. There is something quietly moving in that, if you let it settle. For thousands of years, the space behind the sun was a place people could only wonder about, and into it they poured one of their oldest dreams, the dream of a hidden twin. And we, at last, went and looked, not by moving the sun, but by placing our eyes elsewhere in the sky. We answered a question the ancients could only ask. And the answer, gently, is that we are alone on our orbit. It would be easy to feel that this empties the story of its wonder, but it does not. The wonder was never really in whether the twin was there. It was in the reaching, in the fact that a question first asked in the deep past, about a place no one could see, could finally be settled by human hands. The counter-Earth is not behind the sun. But the looking that showed us so is one of the quietly remarkable things our curiosity has done. And there is a tenderness in the empty answer too. We imagined a mirror of ourselves, always near, always sharing our path, and it turned out the space it would have filled is simply open and still. There is no secret companion keeping pace across the sun. There is only our own single world on its single orbit, lit by the star it circles. The blind spot holds no twin, but it holds no menace either. It is just quiet, and we are just here. So the counter-Earth takes its place among the beautiful things that are not so, the guesses that were worth making and worth, at last, setting gently down. It was one of the first attempts to imagine what hides behind the sun, and it was answered not by dismissal, but by patient looking from every side. The dream is old and lovely. The truth is calm and clear. And both, in their way, are a kind of gift. Yet the counter-Earth is not the only world that people once placed in the sun's glare. There is another, more recent and more scientific ghost, one that troubled serious astronomers for a long while and sent them searching the edge of the sun during eclipses. It too was never really there, and the reason it was not is one of the strangest and loveliest turns in the whole story. To that vanished planet we now turn. The counter-Earth was a dream of the deep past, born of imagination more than measurement. But there was a second hidden world that people believed in for far more careful reasons, and it makes a fitting companion to the first. For a long stretch of time, respected astronomers were convinced that a small planet circled the sun even closer than the innermost planet we know, tucked into the glare, too near the sun ever to be seen against the daylit sky. The story of this supposed planet is, in a way, the most respectable of all the guesses about the blind spot, because it was built entirely on careful measurement. No one imagined it out of a wish for company or a discomfort with the unseen. It was proposed because the numbers seemed to require it, because a real motion in the sky did not quite add up, and a hidden planet was the tidiest way to balance the books. It was a reasonable conclusion, honestly reached, by people doing their work well. That is what makes it such a good lesson. Reasonable conclusions, honestly reached, are not always right, and the blind spot is a fine place to be reminded of it. The searchers were doing everything correctly. They had a genuine discrepancy, a method that had triumphed before, and the diligence to hunt through eclipses and twilights for the object their mathematics called for. And still the object was not there, because the discrepancy had a cause that no one had yet thought to imagine. The place they were searching was, of course, the hardest place of all to look, which only deepened the difficulty. A planet that close to the sun would spend its whole existence in the glare, appearing, if at all, only as a dark speck crossing the sun's face, or a point caught in the shadow of an eclipse. The search carried all the trouble of the blind spot working against it, and none of the reward, because the thing being sought had never been there to find. For a long while the question simply hung open, the leftover motion demanding an explanation, the hidden planet refusing to appear. It was an uncomfortable state, a puzzle with a clear shape but no solution, and it is worth remembering that this kind of discomfort is often where the deepest discoveries are quietly forming. The answer, when it finally came, would not fill the gap with the expected object. It would dissolve the gap altogether by changing what everyone thought they knew about gravity itself. This belief did not come from fancy. It came from a genuine puzzle in the motion of the innermost planet. That planet's orbit is not a fixed, unchanging ellipse. It slowly turns, the whole path itself rotating a little with each circuit, so that over time, the point of closest approach to the Sun creeps steadily around. Most of that slow turning could be explained by the pull of the other planets, but not quite all of it. A small part of the motion was left over, unaccounted for, stubborn. When a planet moves in a way your understanding cannot fully explain, the most natural thought is that something unseen is pulling on it. And the obvious place to hide that something was between the innermost planet and the Sun, in the glare, in the blind spot. An additional small planet there, circling very close to the Sun, would tug on its neighbor and could, it seemed, account for the leftover motion. The reasoning was sound, careful, and entirely in keeping with how such puzzles had been solved before. Indeed, this same kind of reasoning had triumphed elsewhere. On another occasion, an unexplained wobble in the motion of a distant planet had led astronomers to predict an unseen world pulling on it, and when they looked where the mathematics pointed, there it was, a new planet, found almost exactly as foretold. So the idea that a hidden planet near the Sun might explain the leftover motion was not wild at all. It was a proven method, applied in good faith to a real problem. And so the search began for a planet hidden in the Sun's glare. It was a difficult hunt, for all the reasons we have followed throughout this account. A planet that, close to the Sun, would never appear in a dark sky. It could only be caught in the narrow minutes of twilight or in the brief shadow of a total eclipse, when the moon covered the Sun's face and its close surroundings came for a moment into view. The searchers watched exactly those moments, hoping to catch a small dark speck crossing near the Sun. For a time it seemed they might have found it. Reports came in of a small object seen near the Sun, a dark spot crossing its face, a point caught during an eclipse. Each report stirred hope that the hidden planet was real. But the sightings never held up. When they were examined, checked, and compared, they came apart, one after another. What had looked like a planet turned out to be a mistake, or an ordinary spot, or nothing at all. The hidden world kept refusing to be confirmed. Still the belief lingered, because the puzzle it was meant to solve had not gone away. The leftover motion of the innermost planet was still there, still unexplained, still demanding a cause. As long as that small discrepancy remained, the hidden planet had a reason to exist, and careful people went on searching the glare for it, eclipse after eclipse, twilight after twilight, looking for the world that the mathematics seemed to require. The resolution, when it finally came, did not arrive from the blind spot at all. It came from a complete rethinking of what gravity is and of how space and time behave near a heavy body. And it revealed that the leftover motion needed no hidden planet whatsoever. The cause had been present all along, not as an object in the glare, but as a property of the space around the Sun itself. Here is the heart of it, told gently. Near a great mass like the Sun, space and time are not the flat, plain backdrop we usually imagine. They are gently curved by the mass, bent into a subtle shape, and a planet moving through that curved space does not trace quite the same path it would in flat surroundings. The closer it comes to the Sun, the more this curvature matters. And the innermost planet, being the closest of all, feels it most. When that curving of space near the Sun is taken into account, the leftover motion is explained precisely, completely, with nothing left over. The slow extra turning of the innermost planet's orbit is exactly what a planet should do as it moves through the gently bent space near a star. No hidden world is needed. The discrepancy that had launched a decades-long search for a planet in the glare was not a missing object at all. It was a clue about the shape of space. So the hidden planet quietly vanished, not because anyone finally saw that it was absent, but because the reason to believe in it dissolved. The puzzle it had been invented to solve was solved a different way, and with the puzzle gone, the planet was no longer needed. It had never been in the glare because it had never existed. What existed instead was something far stranger and deeper than a small dark world near the sun. Think about the shape of that story for a moment, because it is the whole film in miniature. People looked into the blind spot expecting to find a solid thing, a planet, an object they could point to. They searched with care, in good faith, for a long time. And what they found, in the end, was not the object they were looking for, but a truth about the world that was subtler and larger than any planet, that the presence of a star bends the space around it, and that motion near the sun follows that bending. It is a lovely reversal, and a quiet lesson in patience. The blind spot did not reward the searchers with the thing they wanted. It rewarded them, eventually, with something they had not thought to want, a deeper understanding of gravity itself. The glare kept its supposed planet, because there was no planet to keep, and gave up instead a piece of the deep structure of the universe. Sometimes the emptiest-looking places hold the most. There is a gentleness, too, in how wrong turns out to be part of the work. The searchers were not foolish. Their reasoning had succeeded before and would succeed again. They simply met, this time, a problem whose answer lay outside the tools they had, and their long, patient, fruitless search was part of what finally pushed understanding forward. The planet that was not there did its own quiet service, by being looked for so thoroughly that its absence became a clue. There is a lovely humility in the way this played out. The searchers did not get to announce a triumphant discovery, a new planet found exactly where predicted. Instead, they received, in the end, a quiet correction, an admission that the thing they had sought so carefully was never there, and a deeper truth handed to them almost sideways. Not every honest search ends in the prize it set out to win. Some end in something better, arrived at by the long way around. It is worth remembering, too, that the leftover motion was tiny, a small discrepancy at the very edge of what could be measured. A less careful eye would simply have missed it or waved it away, and the deeper truth it pointed toward might have waited far longer to be found. The whole discovery turned on someone taking a small, stubborn imperfection seriously. The blind spot rewarded not boldness in the end, but a patient refusal to ignore a thing that did not quite fit. So we can set this second ghost down beside the first. The counter-Earth was a dream of the imagination, answered by looking from every side. The hidden inner planet was a careful deduction, answered by a deeper look at gravity itself. Both were placed in the blind spot, and both were found, in the end, not to be there. And in each case, the finding out was worth far more than the thing we had hoped to find. The blind spot behind the sun, it turns out, has a habit of holding not the objects we expect, but the lessons we did not. We keep looking into it for solid things, twins and hidden planets, and it keeps answering with something quieter and more spacious, an empty orbit, a bend in space, a corrected understanding. There is one hidden thing left for us to consider, and it is the most intimate of all, because it is not behind the sun in the distance. It is the far side of the sun itself. The last hidden thing is the most intimate of all, and in a way, the most surprising, because it is not behind the sun in the distance. It is the sun itself, or rather the half of it we never see. The sun is a sphere, a great turning ball of light, and from any single place we can only ever look at one side of it. The other half, the far hemisphere, is always turned away, hidden behind the curve of the star's own body. We almost never think of the sun as having a shape we could walk around, a near side and a far side like any other ball. It is so overwhelming to look at, and so featureless to the unaided eye, that it registers as a flat disk of light rather than as a sphere with a hidden back. But it is a sphere, an enormous one, wider across than 100 Earths set side by side, and like any sphere, it keeps a full half of itself turned away from us at all times. The far side is not a stranger or wilder place than the near side. It is made of the same churning, glowing material, crossed by the same slow weather, ruled by the same deep magnetism. It is simply the half that happens, at this moment, to face away from us. Give it a couple of weeks, and this far side will have become the near side, and the face we see now will have turned away in its place. The sun is forever trading its two faces, slowly, one for the other, without pause. This is true of any ball, of course. Hold an orange at arm's length and you see one side. The back of it is hidden by the front. But we rarely think of the sun this way because it is so bright and so featureless to the naked eye that it seems to have no front or back at all. And yet it does. At every moment, one whole hemisphere of the sun faces us, and one whole hemisphere faces away, into space, unseen. The sun is not a still object, though. It turns, slowly, carrying its features around from the hidden side to the visible side and back again. As seen from the Earth, it takes a little under a month for the sun to complete one full rotation. So a given patch of the sun's surface spends part of that time facing us and part of it facing away, rotating out of view over one edge and returning, weeks later, over the other. This means the far side is not permanently secret in the way the point behind the sun is. Whatever is on the far side now will, in time, rotate into view. But at any single instant, half the sun is simply unseen, and whatever is happening there is happening out of our sight. If we want to know the sun as a whole, a full sphere at a single moment, we run straight into the same trouble that has followed us all night. Half of it is in a blind spot. For most purposes, a hidden hemisphere of the sun might not seem to matter much. But the sun is not a quiet, unchanging ball. It has weather in its own way, regions where its churning and its magnetism gather into active, restless patches, and from those patches it can throw out light and storms. And here is the difficulty. Such an active region can develop on the far side, out of our view, and then rotate around toward us already grown, already capable of hurling a storm in our direction. For a long time, this made the far side of the sun a true blind spot in the most practical sense. A large active region could come around the sun's edge into view, and its arrival could be the first we knew of it. There was no way to see it forming on the hidden side, no warning of what was rotating toward us, until it had already turned to face us. The sun kept its developing weather on the far side and revealed it only when it chose. The first way we found to see past this was to change our viewpoint, exactly as we did with the counter-Earth. If a single vantage point can only see one side of the sun, then more vantage points, spread around, can see more of it. By placing spacecraft ahead of the Earth and behind it in its orbit, off to either side of our line to the sun, we gained 2 extra angles on the star, 2 more windows onto its turning face. With those extra viewpoints working together, and the view from the Earth added in, we could for a time watch nearly the entire sun at once. The near side we always had. The 2 flanking viewpoints filled in the sides and reached around toward the back, until between them the watchers held almost the whole sphere in view. For the first time, the sun could be seen as a complete, turning ball, with very little of it left hidden. The far side had been brought, mostly, into the light. But there is a second way to know the far side, and it is stranger and more beautiful than simply looking from another angle. It turns out that we can learn what is on the hidden hemisphere without seeing it at all, by listening to the sun instead. For the sun rings, very faintly and very slowly, like an enormous bell, and the sound of that ringing moves through its whole body, including the parts we cannot see. Let this settle for a moment, because it is a lovely thing. The sun is filled with sound, with waves that move through its interior, bouncing and traveling across the whole great sphere. These are not sounds we could hear. They are slow, deep motions within the body of the star. But they move through everything, the near side and the far side alike, and as they travel, they are shaped by whatever they pass through. They carry, in their timing, a faint record of the places they have been. An active region on the far side of the sun leaves a mark on those traveling waves. It changes, ever so slightly, how the sound moves through that part of the star, and that change ripples back through the sun to the side we can see. By reading the sound waves emerging on the near side carefully, we can detect the shadow of a large region on the far side, sensing its presence through the entire body of the sun before it has rotated into view at all. The value of that early word is easy to feel. A large active region carries the potential for a storm, a burst of light and particles flung out into space, and if the Earth happens to lie in the way, that storm can wash over us, stirring the upper air and troubling the machines we have come to depend upon. To know a day or two ahead that such a region is turning toward us is to have time to prepare, to steady the systems that need steadying. The far side, once pure blind spot, now offers a little warning. It is a fitting turn in the story that the most intimate blind spot of all, the back of our own star, should be opened not by a bolder look, but by a quieter kind of attention. We did not overpower the sun to see its far side. We listened to it and let it tell us. There is a patience in that approach that suits the subject and suits the hour, to stop straining after what cannot be seen and instead to listen for what the world is quietly willing to say. So we have learned, in effect, to hear the far side of the sun rather than to see it. A great active region forming out of sight announces itself, faintly, in the ringing of the star, and we can pick up that announcement days before the region turns to face us. The blind spot on the back of the sun, once complete, has been partly opened, not by light, but by sound moving through the star and carrying word of what lies on its hidden face. There is something deeply restful in that image, if you let it in as you drift. We cannot see the far side of the sun directly from where we stand. And so, rather than straining to see it, we listen to the whole star ring and let the sound tell us what the light cannot. The hidden hemisphere speaks to us through the body of the sun itself, in a slow, deep voice we have learned, patiently, to read. It is the same lesson we have met again and again tonight, in yet another form. The blind spot did not have to be conquered by force or by ever brighter looking. It was opened by cleverness and by patience, by finding a different way in. With the sunward sky, we blocked the light and waited. With the counter-Earth, we looked from the side. And with the far side of the sun, we stopped trying to see and began, instead, to listen. Even now, of course, the far side is not perfectly known at every moment. Our extra viewpoints shift, our listening has its limits, and there are still times when part of the sun turns quietly out of view. The blind spot has been narrowed, not erased. But it is a very different thing to have a hemisphere you cannot easily see than to have one you cannot know at all. We have gone from a hidden far side to a far side we can sense, and that is a long way to have come. The far side of the sun is a fitting last stop because it brings the whole question home to the sun itself. We began by asking what hides behind the sun in the distance, in the sky beyond it. And we end by finding that the sun hides part of itself as well, its own turned away half, its own developing weather, kept for a while on the side we cannot see. The great concealer of the sky is, in the end, also a little concealed from us. And yet, like everything else behind the sun, the far side keeps no true secrets from us anymore, or very few. It turns steadily, bringing its hidden face around into the light every few weeks, and even before it does, it murmurs its news to us through the body of the star. There is nothing on the far side of the sun that we need to keep watch over tonight. It is simply the back of a turning ball of light, and it is, slowly, coming around. We have reached the end of our accounting of the blind spot, and found it, at every turn, quieter than the imagination feared and richer than it hoped. There remains only to gather it all together, gently, and to let it settle into a single, restful thought before we let the day go entirely. So let us draw the threads in, one last time, and see what the whole of it comes to. Let us draw all of it back, gently, to a single image. The sun is the center of our days, and the source of almost all our light. It is the thing our whole world is arranged around, the fire we circle, the warmth we live by. And it is also, in the exact direction it lies, the one thing we are never allowed to look past. We orbit it, we are lit by it, and in its direction there is a piece of the universe simply held out of our sight. We have spent this long, slow evening walking around the edge of that hidden place, and it is worth remembering now everything we found there. We found that the sun stands in front of a different part of the sky each season, hiding the constellations and even the crowded heart of the galaxy in their turn, and then letting each of them go, exactly on schedule, back into the night. We found a family of small asteroids circling entirely inside our own orbit, warm and lit and almost never seen, not because they are faint, but because they keep too close to the light. We found comets falling quietly toward the sun, seen only in their final hours, brightening beside a covered disk and then unmaking themselves in the heat. We built ourselves a small eclipse and watched a whole hidden traffic move through the glare. We found a point in space that sits behind the sun forever and discovered that nothing rests there for long, that it is a balance too delicate to hold a guest. We followed the oldest dream of a twin world hidden behind the sun and found the space it would have filled to be open and still. We followed a careful search for a planet in the glare and found in its place a gentle bending of space near the sun's great mass. And we found the far side of the sun itself, its own turned-away half, and learned to hear it ringing when we could not see it. Notice what the blind spot never held. It never held a monster waiting in the dark. It never held a hidden twin keeping secret pace with us, or a shadow planet tugging at the others from concealment. For all the long history of wondering what might be behind the sun, the answer, gathered together, is quiet and kind. There are small stones we are slowly counting. There are comets on their last fall. There is an empty balance point, a curve in space, and the slow turning of our own star's far face. The blind spot, it turns out, is not a place of dread at all. It is simply the part of the sky that lies in the one direction the light comes from. And the things in it are the ordinary, beautiful furniture of a solar system, rock and ice and gravity and light, going about their business, whether or not we can watch. The fear was always ours, brought to the darkness from outside. The place itself was only ever quiet. There is a kind of peace in accepting a blind spot, once you see it clearly. We are so used to wanting to see everything, to leaving no direction unwatched, no corner unlit. But to live beside a star is to accept that there will always be one direction, the brightest one of all, that we cannot look into and must simply take on trust. The sun asks that of us in exchange for everything it gives. It is not a hard bargain, and the trust is well placed because the not seeing has never yet hidden anything that meant us harm. Season after season, Age after age, what goes behind the sun comes back around, unchanged and unthreatening, exactly where the quiet mathematics says it should be. The constellations return to the dawn. The comets complete their falls. The far side of the sun turns steadily into view. Nothing that hides behind the sun stays hidden out of malice. It is only, for a while, on the far side of the light. There is a wider comfort hidden in all of this, beyond the sun alone. So much of what we fear in the universe is simply what we cannot yet see, and so often, when we find a way to look, the fear turns out to have been unfounded. The dark was never full of the things we imagined. It was full of rock and light and slow, lawful motion, going on peacefully without us. The blind spot behind the sun is only the nearest and clearest example of a gentler truth about the whole of the sky. It is worth carrying that gentleness with you, softly, as the night deepens. The universe is not arranged to trouble us. It is arranged by simple rules, patiently followed, that fill even the places we cannot see with ordinary and beautiful things. What hides behind the sun is not an exception to that peace. It is a small, warm piece of it, kept out of sight not to worry us, but merely because that is the one direction the light itself happens to come from. So let this be the thought you carry down into sleep, if you carry any at all. There is a place we cannot see, and it is quiet, and it is kind. It holds no watchers and no waiting things, only the ordinary and beautiful furniture of a solar system going gently about its business. The one direction we are not allowed to look is also the one we least need to fear, and there is a deep and simple rest to be found in knowing that. And when the day comes again tomorrow, and the sun climbs back into the sky and hides its piece of the heavens once more, there will be nothing new to fear in it. The same quiet things will be there, behind the same brightness, going on exactly as they always have. You will not be able to see them, and you will not need to. It is enough now simply to know that they are there, and that they are calm, and that they will keep. So we can let the blind spot be, tonight, exactly as it has always been. There is a direction we cannot look, and it is the warm and shining center of our sky, and behind it there is nothing we need to guard against or hold in mind. The one place we are not allowed to see is, in the end, one of the most peaceful places there is, precisely because it asks nothing of us but to let it stay quiet. Let your attention come down now, slowly, from the sky. We have followed the light all the way around, past the hidden constellations and the circling asteroids, past the falling comets and the empty point behind the sun, past the dreams that were not there and the far side we learned to hear. There is nowhere left to go, and nothing left to watch. The whole of the blind spot is accounted for, and it is calm. And so we leave the space behind the sun as it has always been, not empty and not frightening, just a piece of sky held gently out of sight by the nearest star. There is nothing hidden there that you need to keep watch over tonight. Let the brightness go. Let your thoughts drift down from the sky and settle. Let your breathing slow, and let the quiet behind the sun be a quiet you can rest in. Sleep well and good night.